Every road eventually reaches an intersection. Every railway reaches a station. Every airline depends on airports. The internet is no different. Thousands of independent networks exist around the world, each built by different companies, different governments, different organizations. But sooner or later, those networks must meet, because information cannot remain inside a single network forever. A message sent from your phone may cross several different networks before reaching its destination. A video may travel through another company's infrastructure. A cloud application may rely on dozens of independent operators. The internet appears to be one giant system. In reality, it is thousands of separate systems working together, and they all need a place to connect.
These places are called Internet Exchange Points, or simply IXPS. From the outside, many look like ordinary commercial buildings. Few windows, minimal signs, heavy security. Nothing suggests they are among the most important facilities in the digital world. Inside, the picture changes completely. Thousands of fiber optic connections enter the building. Routers exchange enormous volumes of traffic. Networks communicate directly. Cloud providers, internet service providers, content delivery networks, universities, financial institutions, government agencies, all sharing one common objective: move information as efficiently as possible. Most people will never visit an internet exchange point, yet their daily digital lives depend upon them.
Imagine traveling across a city. Instead of driving directly to your destination, you are forced to take a long detour through another country. The journey becomes slower, more expensive, and completely unnecessary. The internet once faced similar challenges. Networks often depended on indirect routes. Information traveled farther than it needed to. Internet exchange points solved this problem by allowing networks to connect directly. Traffic follows shorter paths, latency decreases, costs fall, performance improves. The result is almost invisible. Websites load faster, videos start sooner, online games respond more quickly, cloud applications feel more responsive. The user notices speed, but rarely understands where that speed comes from.
The internet is often described as a technological achievement, but it is also an achievement of cooperation. Every independent network controls its own infrastructure, its own policies, its own business decisions. Yet every day, these networks agree to exchange information, sometimes without payment, sometimes through commercial agreements, sometimes because cooperation benefits everyone involved. This process is known as peering, a concept almost invisible to internet users, but absolutely essential to the internet itself. Without cooperation, networks become isolated, routes become inefficient, costs increase, performance declines. The internet works because competitors often become partners, quietly, automatically, every second, across the entire world.
Every second, billions of digital interactions move across the internet. Search queries, video streams, cloud applications, financial transactions, artificial intelligence requests, and private communications. Much of that traffic passes through internet exchange points, not because they own the internet, but because they connect it. An internet exchange point functions like a major transportation hub. Traffic arrives from many directions, changes routes, and continues toward its destination. The larger the exchange point, the more networks it can connect, the more efficient the internet becomes. Some of the world's largest internet exchange points exchange traffic measured in terabits per second, volumes so large that they are difficult to imagine. Yet all of it exists for a simple purpose: helping information find the fastest path possible.
The internet rewards speed, not just high speed, efficient speed. A delay of a few milliseconds may seem insignificant. To a human, it often is. To financial systems, cloud platforms, online gaming, artificial intelligence, and global businesses, it can matter enormously. Every network constantly seeks better routes, shorter routes, more reliable routes, less congested routes. Internet exchange points help make those routes possible. By reducing unnecessary distance, information reaches its destination faster. Users experience smoother services, businesses deliver better performance, and the entire ecosystem becomes more efficient. The internet feels instant because countless infrastructure decisions are constantly being optimized behind the scenes.
Not every city occupies the same position within the internet. Some cities became digital crossroads, places where networks naturally gather, places where infrastructure concentrates, places where connectivity becomes an economic advantage. Amsterdam, Frankfurt, London, Singapore, Tokyo, Ashburn. These cities became important for many reasons: geography, economics, infrastructure investment, network density. Over time, more networks attracted more networks. More connectivity attracted more businesses attracted more investment. A powerful cycle emerged. The result is a new form of geography, digital geography, where the most connected locations often become the most influential locations in the digital economy.
Critical infrastructure must prepare for failure. The internet is no exception. Cables can be damaged, equipment can fail, power outages can occur, natural disasters can disrupt operations. The solution is resilience. Networks build redundancy. Alternative routes remain available. Traffic can be redirected automatically, often within seconds, sometimes without users noticing at all. This resilience is one reason the internet has become remarkably reliable. No single building controls everything. No single network carries everything. No single route supports everything. The internet survives because it was designed to adapt. And internet exchange points play an important role in that resilience, providing multiple paths through an increasingly connected world.
When a website loads instantly, most people thank their internet connection. When a video begins without buffering, they credit the streaming platform. When artificial intelligence responds in seconds, they assume powerful computers did all the work. But speed begins much earlier, long before information reaches your device. It begins inside infrastructure, inside internet exchange points, where independent networks connect directly, where unnecessary distance disappears, where millions of routing decisions happen every second. These facilities do not create information, they create efficiency. And in the digital economy, efficiency becomes speed. Speed becomes productivity. Productivity becomes economic value. The faster information moves, the faster businesses operate, markets respond, ideas spread, and innovation accelerates. Behind every fast internet experience, there is an invisible architecture working continuously, quietly reducing the distance between people, businesses, and the world's information.
The internet appears simple. Open a browser, touch a screen, press a button. Everything responds almost instantly. But beneath that simplicity exists extraordinary complexity. Thousands of independent networks, millions of kilometers of fiber, countless routers, hundreds of internet exchange points, all working together every second without asking for attention. The internet was never designed as one giant machine. It became a global system because thousands of independent systems learned to cooperate. That cooperation became infrastructure. That infrastructure became reliability. And that reliability became the foundation of the digital economy. The websites we visit are only the surface. The applications we use are only the interface. Beneath them lies an invisible architecture connecting the modern world. An architecture built on trust, engineering, redundancy, and collaboration. Because before information could connect humanity, the networks themselves had to learn how to connect each other. In the next episode, we step inside the buildings where the internet truly lives. Facilities that never sleep, consume enormous amounts of electricity, and quietly power nearly every digital service on Earth. The story of the modern data center. NEXNET, the architecture of modern civilization.